Hello and welcome to another video. This time we will use the spatial analysis tools. More specifically, we will discover which are the most dangerous streets in the city of Adelaide, Australia. As the input data, we will have the density of accidents, accidents with fatal victims, accidents with serious and minor injuries, and finally, the speed limit of each street to be analyzed. You will also learn how to use several tools, such as buffer, raster calculator, lookup, fuzzy membership, and much more. Finally, we will explore the multi-criteria analysis, namely Analytic Hierarchy Process or AHP, which will help you in decision making. So, without much further ado, let's go to the video. Okay, let's start the project by adding the data we are going to use. So let's click right here on Add Data. I will go to my desktop, YouTube tutorial, data, and I will select Adelaide City, Adelaide Streets, and the CSV with the Adelaide crashes. Here in green we can see the Adelaide City, so our study area, and the roads or streets we are going to analyze. Clicking on the CSV file, we see that we have crashes with fatal victims, crashes with serious injuries, and then crashes with minor injuries, and the X and Y coordinates. Talking about coordinates, we can check the coordinates for this project. So here in source we can see that the special reference is GDA 2020 South Australia Lambert, and for the map the same as the feature classes. The first thing we are going to do is transform the CSV file into a shapefile. So let's click right here and transform this table into points. So let's give it a name and save it on our folder. I will call it Adelaide _crashes. The X field will be the X coordinate, Y the Y coordinate. Let's click on OK. And there we have our points in the map. And if we click right here, for example, we see that the fields are the same as the CSV file. Okay. We can remove it, and I will remove the study area as well, because actually I think we are not going to use it at all. So the next thing we are going to do is create a buffer. To do that, let's go to Analysis, More Tools, search for Buffer, and it will be a buffer of the Adelaide streets. So let's drag and drop the Adelaide streets and choose the output. So right here, I will call it Adelaide _streets _buffer. We'll click Save. First, I'm going to change this to dissolve all output features into a single feature, and the distance will be in meters, and I will type 10 meters. Let's see here, and right here we don't need to change anything. Okay. Let's click on Run. And as you can see, here we have our buffer with the distance of 10 meters. Now let's create a mask. To do this, let's search for Polygon to Raster. Let's click here. Let's drag and drop the buffer. Choose your output. we'll call it mask, and I will just change the cell size to 5 meters. Click Run, and a mask will be created with a 5-meter distance between each pixel. I will hide our mask, and then we will analyze the different variables that we will use. So I will drag this Excel to show you the 5 variables. So the crash densities, accidents with deadly victims, serious injuries, minor injuries, and to finish, the maximum speed limit of each road. The first one we are going to analyze will be the crash density. So let's go back to ArcGIS Pro and let's search for kernel density. Select this one. I will drag and drop the Adelaide crashes. Population field, none. I will select the output raster and save it to our folder. I'll call it KD_crashes. Let's just search for our folder right here. The cell size will be 5 as well. Here we are just going to select the barriers and let's select the buffer. Environments, current map, extent will be the buffer, and for the mask and snap raster will be our mask. And click on Run. Let's wait a second. And we have the density of accidents on the limits of our roads. We can see here the minimum and the maximum value. And what I actually like to do is change the symbology from green to red. So I will change the colors right here. Select 3 classes, the lower ones with the green, in the middle yellow, and the red color to the bigger ones. Okay? And as we can see, the road segments in red where there was a higher density of accidents. For example, right here or right here. Okay? For example, here in yellow, or the red here. And where there is a lower density of accidents, the color green was assigned, as we can see. For now, I won't touch this feature anymore, since later we will normalize these values. So I will unselect this one and hide it. In the next step, we will carry out a spatial analysis of accidents with fatal victims, serious injuries, and minor injuries, giving greater weight to areas of our map where these events occurred. Let's search for EDW, and let's start by drag and drop our crashes, and for the Z field will be accidents with victims, so fatal. Let's save this to our folder. I will call it EDW fatal. The cell size will be 5 as well. Now let's go to environments, change the coordinate system, the extent will be the buffer, and the mask and the snap raster will be the mask. Let's click OK, or run actually. Let's now change the symbology of the EDW as well. Let's change this to 3. Go to symbology. Let's change this to continuous. And change this to green, yellow, and red. Click OK. And as you can see, we have the spatial representation of accident with fatal victims, and in the areas where people died, it has a greater value compared to all the others. For example, this one, or right here, yes, it has one fatal victim here as well. I think the rest of the map is colored green, that is a much smaller weight compared to the areas in red. I will hide this EDW as well, and let's proceed to the next analysis. So let's click on EDW again, drag and drop the Adelaide crashes, but this time we will analyze the serious injuries. Let's save it to the same folder. Once again, EDW underscore SE, click save, cell size 5 meters, and right here we do the same process. Mask here and mask here as well. Okay, let's once again change the symbology. 3 classes. Let's change the symbology here for multipart to continuous. Add 1 and change the colors. And let's check how the map went, okay? And this time, as there were many more serious injuries compared to fatalities, it is normal that the map is not so green, okay? For example, let's check this point right here. Yes, as you can see, we have a serious injury right here. Here we don't have it. We have already 3 variables represented, so let's move to the next one. I will hide it right here. Let's search for the EDW once again. And now we will represent the minor injuries. So it's the same process as the previous one. So let's save to this folder. EDW underscore MY, cell size 5, and let's repeat the same process to this one. Okay, and click run. This time I believe we will have an even more colorful map. Let's check if this is true. So let's change the symbology once again to our 3 favorite colors. So continuous, green, yellow, and red. Okay. It's not as colorful as the previous one, but we can see a greater amount of red. So the reason for this to happen is that there are many more minor injuries compared to serious injuries or even fatalities, okay? The classes are not distributed equally, but we will normalize everything in the end. So we have already represented the three types of victims, so fatal, serious injuries or minor injuries. And now we need to represent the speed limit for each street, okay? To do this, we will do a little bit different. First, let's search for the buffer once again. Let's drag and drop the Adelaide streets. Change the output to our folder. We'll call it Adelaide underscore streets underscore buffer underscore analysis. Let's click on save. And this time we are not going to change the dissolve type because we don't want a single feature but multiple features, okay? The meters will be 10 as well. Environments, we just change the extent to the previous buffer, okay? Let's click on run. And as you can see, we have the buffer of the streets, but each street is a single feature, okay? Or a single element of a feature. Let's remove the Adelaide streets because we are not going to use it. And now I will transform this shapefile into a raster, okay? To do this, search for Polygon to raster because this is a polygon. Drag and drop the buffer analysis. Value field will be the speed limit of each street, okay? You can check it on the attribute table right here. Each street has a speed limit. So let's search for speed right here. Okay. Change the output once more. I will call it PTR underscore, for example, speed. Cell size will be 5 as well. Environments, it's the same as the previous, okay? Buffer for the extent. Snap raster will be mask. And now we can click on run. And we have our streets with the speed limit, okay? Let's unselect this one. And as you can see, 50 kilometers per hour gray, 60 greens, and 100 kilometers per hour with the red color, okay? Obviously, the maximum speed of different roads has different weight when we want to do an analysis for this type, okay? There is, as a rule, accidents on high-speed roads tend to be more serious, and that is why we will give different weights to each speed limit, okay? Let's search for add field. Drag and drop the PTR underscore speed. For the field name, I will call it power. The type will be float, right here. And that's it. Click run. Let's open the attribute table. And there we have our new field. Now we are giving weights to the 3 different speed limits, okay? We know, as a rule of thumb, that the higher the speed, the greater the probability of an accident being more dangerous, okay? So we will give different weights to different speed limits. So 100 kilometers per hour, I will give it 50% of the weight, so 0.5. The 60 kilometers per hour, 0.35. And for the 50, 0.15, so 15%. Okay, let's save our project and our edits so we don't lose our process. Okay, let's clear the selection. And now we have all the variables defined, okay? And now we will analyze our data on a scale of 0 to 1, with 1 being the value with the most weight in our analysis. So, why is this process necessary? It's always necessary to normalize our values because we cannot compare, for example, the density of accidents, in which the maximum value is 1,300, with the maximum value of serious injuries, for example, in which the maximum value is 5. So, in other words, we have to put everything on the same scale, okay? Let's normalize the PTR underscore speed. So let's search for the lookup tool, drag and drop the speed raster, okay? The lookup field will be the power. What this does is changing the value of the raster. So in this case, from the value to the power. Let's select and give the name to the output. And in the environments, we do the same process as the other ones, okay? Okay, click run. And there we have our raster with the percentage for each road, okay? We can now remove the PTR speed because we are not going to use it anymore. And now let's proceed to do the normalization for the other rasters, okay? So to do the normalization, we are going to use the fuzzy membership tool, okay? So let's search for fuzzy membership. What this does is normalize the values from 0 to 1, okay? Let's start by the minor injuries. Okay. Here, let's save or select the output. I will call it n_my and click save. For the type of membership, it's important to choose always taking into account the variable you are analyzing. In this particular case, I will use linear, okay? Extent will be the buffer, and mask, snap raster, the mask as well, okay? And I'll click on run. So, the bigger values represented by the whites, so the value 1, and the lower values with the dark colors, okay? And if we compare to this one, we can see that it's correct, okay? Now, let's do the same process for the serious injuries, okay? So first let's remove this one, and let's do the same process for the serious injuries, okay? Let's drag and drop, save it to the folder. This time I will call it n_sy. I will choose linear as well and change the environments to this one as well, okay? Mask right here, and click on run. Again, we can see that the serious injuries are represented, or the higher values are represented with the lighter colors, so the whites, and the lower values with dark colors, okay? So the blacks. Let's remove this one as well, and let's finish the fuzzy membership tool with accidents with fatal victims, okay? Let's change it and give the name to n_fatal, linear as well, and for the environments, buffer for the extent, and mask for the mask and for the raster, okay? And as you can see, we can actually notice where the accident with victims occurs, so in those two places. And now let's finish with the normalization of the kernel density, so this density of crashes, okay? So actually we will use the fuzzy membership once again. So let's give the name of n_crashes or crash density to follow the same name. Use linear as well and change the environments, okay? Mask will be not buffer but mask, snap raster mask. And we have the densities with on a scale of 0 to 1 as well, okay? And if we compare this to the kernel density, we can see that the higher values in white are the same on the other one, but in red or yellow values, okay? Let's remove the density. And the next step is to define different weights for each of these variables, okay? So for example, accidents where there were fatalities must have a higher weight than an accident where there were minor injuries, for example. To define what weight to give to each variable, we will use a multi-criteria analysis, so using the Analytic Hierarchy Process. To help us in this process, we will open this Excel file that will support us in the decision making. If you want this Excel file, leave a comment on this video and I can share it without any problem. In AHP multi-criteria analysis, we always compare the row variable with the column variable in terms of importance, okay? So for example, I will compare the crash density with fatal crashes, okay? And for me, crash density are moderately more important than fatal. So relative to the column, the row variable is moderately more important. So I will give it the number 4, okay? Now let's compare the crash density with serious injuries. So if fatal is 4, the serious injuries needs to be higher. So I'll give the number maybe 5, for example. And minor injuries needs to be higher as well. So for me, crash density is almost extremely more important. So I'll give the number 8. Crash density and speed. I think crash density is important, more important, but not so important. So I will give the number 2. So is equally important, okay? Now comparing fatal crashes with serious injuries, okay? Obviously, fatal crashes are more important than serious injuries. So in this case, for example, I will give 6, so much more important. Fatal crashes and minor injuries obviously is way more important than a 6, so I'll give 8. And for me, speed is more important than fatal crashes. So what we need to do right here, we go to the warmer values. So for example, for me is 1/4. So relative to the row, the column variable is moderately more important. So I will place 1 divided by 4 on that cell, okay? Now let's compare the serious injuries with minor injuries. So serious injuries are more important. I will choose, for example, the number 4 is moderately more important. And for me, in my opinion, the speed limit is more important to analyze the street crashes, okay? So I will choose, for example, relative to the row, the column variable is much more important. So speed is much more important than serious injuries. To finish, let's compare medium injuries and speed. And for me, speed is actually more important. So 1 divided by 8, so is almost extremely more important. Now that we have our values, we need to do a normalization. To do this, we duplicate our table and we do the value of the cell divided by the sum of each column, okay? And then we do the average for each row, and then we have our weight. So in this case, crash density will have a weight of 41%, fatal crashes 18%, serious injuries 7%, minor injuries 3%, and speed 31%, okay? So we will use these values to do our final analysis to the map. I will place the Excel right here, side by side with our ArcGIS project. And now let's finish the video by doing the final analysis with our 5 variables, okay? To do this is super easy. Just search for Raster calculator. And now we are going to do a sum of each variable, but representing each of the variable weight of our Excel, okay? I will double click on every variable, and now, for example, for the crash density, I will open the parentheses and multiply it by 0.41%, okay? So 41%, 0.41, and then you do a sum. So you do a sum of each variable, but before you do a sum, you need to multiply it by the weight, okay? And you do this for every variable, okay? So fatal crashes 18% plus open parenthesis, serious injuries will be 0.07, so 7%, plus open parenthesis, minor injuries is 3%, so 0.03, and the final is the speed. So the speed will be 31%, so 0.31, okay? Click on multiply, 0.31. Now let's select the output. I will call it, for example, RC underscore crashes. Environments, we do the same process. So the buffer for the accident and the mask right here and right here. And let's click on run. And a parameter is missing or invalid. So let's see what is missing. Okay, maybe those spaces. Let's see. Okay, let's do a backspace right here. Let's try again. Okay, right here as well. Okay, something is missing. Let's try to give spaces in all of the variables and the weights like this. Let's see if this works. Okay, let's try on. Okay, no. Okay, maybe because, okay, I know what it is. It's because Yeah, we have commas and we cannot have commas actually. It's points. So let's change the commas to points. Okay, and I think that now it will work, okay? And is working, okay? And let's check the final result. Let's wait a second. There we have. Let's check the final result, okay? So we have a map between 0 and 0.5. Let's change the symbology once again. Okay, green here, yellow, and the higher values with red. And now let's reclassify these values. So we need to standardize our map. So we are going to choose a representation with the standard deviation. Okay, so to do this, just go to Analysis and search for Reclassify. Okay, drag and drop the raster calculator crashes, and we will classify it by the value and choose standard deviation as the method. Okay. Now the values will be defined on a scale of 1 to 5, so the 1s will be the lower danger or very low danger, and the 5 the very high dangerous roads. Okay. Now that we have a name, let's click on Save. Let's change the environments as well. Buffer and mask and mask. Okay. Now we have the same map, but the values are aggregated differently. Let's add a new field to this one. I will call it danger. The type will be text. Let's click run. And as I said, the number 1 will be very low danger. 2 will be low. 3 medium. The 4 will be high. And the number 5 will be very high. Okay. Let's unselect and collapse these variables and do our final representation. So change this to danger. Let's adjust the value, so very high to the bottom and very low to the top. So let's move very low to the top. Okay, it's correct, and change the colors again. Okay, medium with yellow, high with orange, and very high with the red. And this is how you can build a map of the most dangerous streets for car accidents, in this case of the Adelaide city. With the representation of a map of this type, we can actually have better knowledge of a given territory and any phenomenon that can be analyzed geographically. Okay? So if you have any questions, don't hesitate to ask in the comment section. I know that sometimes this type of analysis can be a little tricky and a little bit difficult, okay? Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.